So what is Cisco Cloud Center comprised of? What are the basic components of Cloud Center? Well, first off, first and foremost, we're going to talk about the Cisco Cloud Center Manager, the CCM. This is where the magic happens. This is the central repository of truth. This is where all the configuration for Cloud Center is kept. This is where the application models are stored. And this is where the marching orders are given from the Cloud Center to the other components. So this is also where the API is. So we've got a REST-based API. And then if you want to do configurations on Cloud Center, then you come in through some sort of API client. API client there. Or you come in through the HTML5 based GUI. So thankfully it's HTML5 and not any sort of Java. So we have the Cloud Center Manager. The Cloud Center Manager itself is comprised of an application server, and then on the back end there's actually a database. The database is the important part in terms of the configuration because that is where the state is stored for the entire Cloud Center installation. So a Cloud Center itself is an application, and as we talked about, applications have a state. The state for Cloud Center Manager, the state for all of Cloud Center is stored in this database. This is a PostgreSQL database, so you can do backups of this database, restores, etc. And that's the thing to keep safe. There is the ability to run Cloud Center Manager in a active standby scenario. So you can run 2 instances of Cloud Center Manager and 2 instances of the database where they sync up. So that's an option. That's an option if you want to do it that way. Although, and this is kind of a little bit of a paradox here, you can run everything on a single virtual machine, or at least the Cloud Center Manager along with the database on a single virtual machine, and you treat it like a pet. So you back up that virtual machine. You can run something like Site Recovery Manager for that virtual machine. So that virtual machine is destroyed, then you can just do a restore. Or you can treat it like cattle and then make sure you have backups of the database itself, and then you can do a recovery and an install of Cloud Center Manager. You can run separate, if you really need scalability, that means you've got lots of tenants and dozens or hundreds of applications, or dozens or hundreds of applications. You can run... You can split out your Cloud Center Manager application server, run those on a VM, and then you would run your databases on 2 other sets of VMs. Let me put this in here. So you would run a total of 4 VMs if you really needed the scalability, you really wanted to separate out that functionality there. And you would need some sort of load balancer. It doesn't really matter what type. Could be an F5 that you have around, or you can set up AJ proxy or something like that. You need a load balancer to divide traffic between the 2 active Cloud Center Managers. And then the databases would be active standby, doing a synchronous replication between them. So that's, of course, all an option there. To be honest, most customers, at least starting out, and just because you pick one method doesn't mean you have to you have to stick with it. You can migrate to multiple VMs at another point, but most of the time we're going to run Cloud Center Manager on a single VM along with its database, running PostgreSQL, all on the same server. And then we're going to use our built-in VMware tools to treat this like a pet. You can put Cloud Center Manager anywhere. You can put it in Amazon. You can put it in Azure, any of the platforms that are supported by Cloud Center. But probably 99% of the customers will put Cloud Center Manager in your private data center in vSphere. So it's almost always a vSphere VM. To install it, there's a couple of different ways you can install it. They're different color here. There is an OVA that you can download for vSphere and load it up, and it contains a pre-configured or mostly configured installation of CentOS along with all the hardware or all the software components. Like it actually runs a Tomcat server inside, Tomcat and Postgres and everything. So everything's all set up. You just have to answer a few questions, or you can install a generic CentOS server. So just start up a generic CentOS server. And then you run through an installer from a single installer file. So installing is so we have the installer script. So installation is pretty simple, pretty straightforward. So that takes care of that, and that's CloudCenter Manager. There's an optional. You don't have to run it, but it'll typically run alongside wherever you put your CloudCenter Manager. You'll run it nearby. Typically, you have the CloudCenter, and this is the monitor. And what CloudCenter Monitor does is it keeps an eye on your cloud installations to make sure that your components in the clouds are working, that the accessibility is up to those cloud environments. And it also keeps an eye on some of the aspects of the VMs that are started up by CloudCenter. It is not meant to replace. It is not meant to replace your like Nagios or SolarWinds. It's not meant to replace all of your monitoring faculties. It is just there to monitor the VMs and the components for CloudCenter Manager. And when it monitors the VMs that CloudCenter starts, it's only monitoring a small portion of what they do. So you're still going to want to have a separate set of monitoring tools. It doesn't mean you can get rid of those. Again, these are typically installed on vSphere locally. Now, if you're not running vSphere, that's fine. You can. I've had at least one installation where they weren't running vSphere; they were running actually OpenStack, and they ran CloudCenter Manager and CloudCenter Monitor on OpenStack, and that's fine. But typically, it's done in-house on your private on location or on-prem, as the kids say these days. So we've got CloudCenter Manager. That's where the magic happens. There's the API interface. And then you can also come in through the HTML5 based GUI. So you hit the API directly or the HTML5 based GUI. There is a CLI that you can run. It does most of the stuff that you would do through the GUI or the API. But typically, it's most of the operations are done through the GUI or through the API. Next up is in the cloud environment. So let's say I've got a vSphere server here. So this is my vSphere cluster. And the vCenter. So I've got vCenter running. So this should actually be, let me do that again, vCenter. So vCenter is the VMM, the virtual machine manager. And typically it's a pair of them running active standby. And then I've got a cluster of systems. That's going to be considered a cloud environment. So what we're going to need for every cloud environment is we're going to need two things. One is we're going to need a CCO, a CloudCenter orchestrator, and we're going to need an AMQP server. So these are two VMs, and then the instruction guide tells you how to size them. And same thing for the CloudCenter Manager. It tells you how many vCPUs you need, how much RAM, what kind of disks you should expect to be able to put onto it. Same thing for the CCO and AMQP. So what they do is, so the CCO is the CloudCenter orchestrator. The CloudCenter orchestrator is actually making the API calls to vCenter. It's not the CloudCenter Manager. Even if they're sitting right next to each other, even if they're running on the same ESXi host, CloudCenter Manager and vCenter do not talk directly. The CloudCenter Manager will communicate to the CCO, and the CCO will communicate to CloudCenter Manager back and forth. So we need bidirectional connectivity here. And what the CCO does is it gets the instructions. So CCM says, okay, I've got an application. Maybe it's like something like IPAM, and I need to install this onto vCenter. So it sends the commands to vCenter. And what will happen then is that CCO will then start up the VMs. And as the VMs start up, Let's say this particular application was a 2-tier application, and it needed 1 VM per tier. So a pretty simple application, maybe a web server and a database server. Maybe this is something like WordPress. WordPress is a pretty simple installation. Typically has just a web server and a database server. Maybe they're even on the same VM, but just for argument's sake, let's say there's 2 separate VMs. When the VMs start up, they're going to need to. We're gonna have to do a lot of work on these VMs. Remember that blueprint. We have the application model up here. So this application model has specifications for where to get all the artifacts, where to put the artifacts, etc. And that's handled through the AMQP. So the AMQP it stands for Advanced Messaging Queue Protocol, and the actual application is called RabbitMQ. So these are applications that we use to disaggregate state between different components of a system. But it really helps us keep track of all the tasks that need to happen. So these VMs have a little agent running on each of them. They're communicating with AMQP. So they know, and then the AMQP is telling them where to go in terms of, and the CCO is telling them where to go in terms of things like the repository. We have somewhere sitting on the public cloud, or the public internet rather, is the Cisco CDN. Cisco Content Delivery Network. There are 2 components on the Cisco Content Delivery Network that are related to CloudCenter. One of them is the, let's see if I can use the text here, bundle store. And the next one is the package store. So these are 2 places where the VMs are going to pull things like Debian packages, Ubuntu Debian packages for Ubuntu, RPMs for that are specific to the CloudCenter installation, and as well as a couple other components that it needs to get. So that comes off of the Cisco CDN. Your VMs need to be able to communicate outbound. They need to be able to make outbound internet connections to these bundle store and package stores. Again, these are run by Cisco, so they're populated by Cisco, so you don't have to worry about them. But your VMs do need to be able to make an outbound connection to them. In limited cases, we've run into where customers, because of whatever security profile that they have, those VMs cannot make an outbound connection to the internet. So what you can do is you can make a, in fact, I'll just highlight all these. You can make a replica, kind of a mirror that you run locally. And so this wouldn't be a Cisco CDN. This would be a local. So what would happen is you would start up these VMs, you would pull down basically a mirror of the actual what's on the Cisco CDN, and then present them locally so that your VMs can get to them locally. You don't need to do this unless your VMs cannot make outbound connections. We don't normally have to do that, but every now and then we run into a customer that has that as a requirement because potentially of a security requirement. So we've got the CCO, we've got the AMQP, we've got the CCO communicating with vCenter, the AMQP communicating with the CCO and with the VMs. Next up, let's talk about cloud providers. Now, probably one of the most common ones is Amazon, so let's go ahead and do AWS. Now, just like vCenter, we're going to need a separate instance of a CCO. Oops, very small O there. And an AMQP. Now, you're going to need a CCO and an AMQP VM. On Amazon, these need to run perpetually. So this will be the cloud for the Amazon public cloud. And this is going to be just a single region. So this will be Amazon West in Oregon. If you also had Amazon East, they would also need their own pair of CCO and AMQP. So again, the CCO communicates with the AWS APIs, and the AMQP will coordinate installation tasks with the VMs that get started up. Again, the VMs will also need to be able to connect to the Cisco CDN, but typically for AWS, it's not much of a deal. They don't have to have public addressable space, so these can be on your VPC. Now, when I say VPC, I need to clarify. I'm not talking about a Nexus VPC, which is a virtual port channel. VPC in the Amazon parlance means virtual private cloud, so a private address space specifically for a tenant. Next up, let's say we're doing also Azure. So Microsoft Azure. Again, they're going to need their own CCO, which will communicate with the Azure APIs, and their own instance of RabbitMQ running there locally, and their VMs also will need to be able to connect outbound to the Cisco CDN. So those are the primary components. Oh, and there's one more component that I'm going to need to introduce here, and that's the repository. That's the user-defined repository. Using a less harsh color here. So you're going to have some sort of repo configured. So when you model an application, you're going to tell it, okay, you're going to need to install this WAR file. Here's a configuration file. We need a place to put all of these artifacts. Now, some of these artifacts are stored on the Cisco CDN. So these are the generic ones. For example, when you start up a VM, the first thing that needs to go onto that VM is an image, or is the agent, and we can find the agent on the bundle or package store. Other components we'll need to get from the bundle or package store, things like Apache, Tomcat, or whatever. But your specific application artifacts, things that are specific to your applications, we need you can't upload stuff to the bundle store or the package store. So that's just for the generic baseline installations of CloudCenter. You're going to need to create your own repo. So that repo can be an FTP server. It can be a generic HTTP or HTTPS server. It can be your own private installation of an object data store, such as Swift. Very commonly, it's actually an Amazon S3 bucket. Why an Amazon S3 bucket? It's an object store. It's a great place to put stuff. It's easy to configure and easy to maintain. And then your VMs are going to pull their components, their artifacts from that repo. So they'll need to be able to have access to that Amazon S3 bucket. So we're going to need to set up a repo. So every customer and every tenant will need to have a repo for their application models. You can have more than one repo, that's no problem, but you're going to need to configure at least one so you can put the stuff that you're going to be able to install on your VMs. That's about it. There's one more thing to keep in mind, one more thing that we run into. So I'm going to draw some dotted lines here, or at least demarcation points. So everything in this light blue line, this light blue circle here, this is your on-prem. This is your private data center. One of the tricky aspects that we run into, and we've done a lot of installations for customers and partners at Lumos, and the thing that we need to plan for ahead of time, whenever we do an installation, we give the customers or the partner a checklist. And one of the most important items on that checklist is, how is the CCM going to communicate with the CCO and vice versa? We need to have bi-directional. I'm going to use a harsher color here. We use red. We need to have bi-directional communication here. So if it's local in the same data center, that's usually not a problem. But from Azure or from Amazon, from one of the public cloud providers, we might run into a problem because the CCM might be on a private address space, something like 10.100.1.10. And your local CCO might be 10.100.1.11. So that's not a big deal. But this is a private address space. So if the CCO, which is sitting on Amazon AWS, maybe it's running it on a private address space. Maybe it's running in a VPC. How is it going to communicate with the CCM? And how's the CCM going to communicate with it? Especially this back inbound connection. So the CCO needs to be able to communicate directly to the CCM. Needs to make an outbound TCP connection. So if we're running a non-routed IP space, then we have two basic options. One is to set up NAT. So whatever router or firewall is at the perimeter of this data center, we can set in a NAT rule that will translate public address space into a private address space on the proper port, and those ports are documented. There'll be several that you need to do. Or probably a bit easier is set up a VPN. So set up some type of VPN. So this will be my main VPN concentrator. It'll go one VPN into Amazon, a different VPN into Azure. And then that way, the CCM can communicate into the CCOs of Amazon and Azure and whatever public cloud providers that you have. We just need to be able to make sure that we have that bidirectional connectivity. Most of the time, we have that set up as a VPN. The reason why we send customers a checklist is a lot of organizations don't have the ability to just start up a VPN. It needs to get vetted and maybe even go through change control if they're gonna poke a hole like that, or not really a hole, but have a back-end backhaul connection like that. So it's not something you can typically do. Sometimes you can, but it's not something you can typically do when you get to a customer's site and be like, oh yeah, we need a VPN. Well, that might hold up the installation process entirely. So those are some things. And we also need to make sure that the VMs can communicate outbound. If they can't, then we need to make sure that we have the appropriate resources so that we can set up that bundle store and package store repo or local mirror. So a couple other quick things. The CCM, the CCOs can only register with a single CCM or a single pair of CCMs. So the CCOs are, if you're going to have more than one instance of CloudCenter Manager, then you're going to have more than one instance of CCOs and AMQPs on all of your clouds. But that's not typical. Typically, we just run one instance of CCM, whether that's a single server or in an HA pair. Speaking of which, we do have the ability to do HA pairs of oops, back to my standard color here. We do have the ability to do HA pairs of the CCOs and AMQPs in the cloud environments. So that is an option. Most of the time, we haven't really done that yet. Maybe it's something we'll consider doing as standard practice. Standard practice is to make sure that we have some way to have the CCM backed up and recoverable in case we have a failure or catastrophic failure. But no state is stored on the CCOs or AMQPs. So no permanent state is stored on them. So if we lose them, we just reinstall them. If there's applications running on AWS and we lose the CCO or we lose the AMQP, those applications will continue to run. We'll just lose visibility into that cloud environment, and we'll lose the ability to configure that cloud environment for things like terminate an application or modify an application. So it's not as critical to have these CCOs and AMQPs as HA. But that is now an option, and it's a new option with 4.7. And one more thing, one more small component. There is what we call it's called the Guacamole server. So put that there. It runs on the AMQP system by default, but you can move it to a separate server if you need to. And what that is it provides, put a little G here for guacamole. What it is it provides local SSH, VPN, and or not VPN, RDP and local SSH and RDP access to the local VMs so that you can get a console connected to them. And they cannot be made HA at this point, so they'll run on one of the, if you run HA MQP servers, RabbitMQ servers, it'll run on a single one of those. But again, there's no state on them, so it's not quite as critical to have those components HA. So just a quick recap of the components. We have the Cisco Cloud Center Manager. That's the configuration point, the source of truth, the state of the Cloud Center installation. There's an HTML5 web interface as well as a REST API. You can do HA for Cloud Center Manager, or you can treat it like a pet and do backups of the VM. And there's also other expandability options. Cloud Center Monitor watches over the CCOs. It is optional. It tests the cloud environments. It provides interfaces to do health checks too, and can be made HA, although it's not as critical because it doesn't hold any configuration state. We have the Cloud Center orchestrators. You're going to need one Cloud Center orchestrator per region, even if it's the same cloud provider. For example, Amazon West and Amazon East, each of them will need their own instance of Cloud Center orchestrator. They must register with a single CCM or a CCM instance, and they can communicate directly with the CCMs, and we're going to need bidirectional communication. It's also the part of Cloud Center that actually communicates with the local APIs with Azure, Amazon, vCenter, etc. AMQP runs RabbitMQ. It's an advanced messaging queue protocol. Brokers tasks from the CCO to the agent running on the instances in the VMs instantiated on the various clouds. It can be made HA, although it's not as critical. On the same server also runs a Guacamole service, which provides web-based SSH, VNC, and RDP for the started up VMs. That one can't be made HA at this point. Again, not as critical because these are not components that have configuration state on them. You can run it on a separate server if you want to break it off of the AMQP server for scalability reasons. We have the bundle and package store. The bundle store contains the agents the VMs use. The package store contains Ubuntu, Debian packages, CentOS, RPMs, Ruby on Rails, gems, etc. Components for various services that might be instantiated. Both of them can be made offline if your VMs can't make outbound connections. And then finally, we have the artifacts repo. So this is a user-configured repository. It contains artifacts required for the application, things like binaries, binary war files, jar files, PHP, Python, Ruby files, whatever. Configuration files, SQL dumps. It can be an HTTP server, HTTPS server, FTP server, a generic object store. Typically, it's an Amazon S3 bucket. That's sort of the easiest and most common thing that we see.